So we are having a simple question where we need to solve this equation. We need to know the roots, or you can say the number of solutions of this particular equation. So if I just proceeded to its graph, then definitely I need to know what is the graph of this particular function. So if I look at this x minus 1 our function tend to infinity. So if I just go to and try to make its graph, I think this is something. It is crossing the origin, means I am making the graph of this particular function, that is fx equals x square plus x square upon x plus 1 whole square. So if I just sketch the graph here, if I just solve if this x, it will be 2x x plus 1 to the power 4 x plus 1 square 2x minus of 2 into x plus 1, removing x plus 1 from here. I am getting x to be 2x square plus 2x minus 2x squared. It means 2x upon x plus 1 whole cube. This is I'm getting f dash x equating 0 at x equals to 0, and at x equals to 0 my derivative will be is equals to 0. That means here f dash 0 will be 0, and or x equals minus 1 if I'm not wrong. Well, I think I am wrong, because this will be equal 0 minus 1, and this will be minus 2x minus 2. I'm sorry for the inconvenience. This is minus 2, and this thing at minus 1 it is tending to infinity, you can see here, and at minus 2 we are having, wait a minute, yes, and at minus 2 we are having a value. Let me just remove these terms. I just differentiated it, found that, wait a minute, yes, I just differentiated the function to find the minima and the maxima. If you will differentiate this particular function to find the minimum and the maximum, you will get that at x equals to minus 2 it is having a minima, at x equals to 0 it's having a minima, at x equals to minus 1 it will having a maxima here at infinity. And this will be the situation of this graph if I'm not wrong. This will be something like this, because from 0 to infinity it is a constant increasing function. If you just look at its derivative at x equals to positive, if I just increase the value of x, here f dash x is also increasing, and at here I will get a maxima at minus 1, and because at minus 2 I am getting a minima here, and again a decreasing nature is something like this. We are having an asymptote at x equals to minus 1. At x equals to minus 1 I'm having an asymptote. No problem. So what is the next here is, okay, so if I just look at this particular graph, so I have the graph of this function in such manner, you can see here, and y equals to 3 will be somewhere here if I just look at it. So we are having two real roots here and two imaginary roots. So you guys telling that there are two imaginary roots of this particular equation, because if you just go to solve this particular thing, this will be a form of a biquadratic equation, and a biquadratic equation have four roots, where here two roots are imaginary and two roots are real, as the two roots can be represented in our graph. So how we can solve this particular game? So let us considering x equals a equals to x and b equals to x upon x plus 1. We are having a situation a square plus b square is equals to 3, which we can represent in the form a minus b whole square plus 2ab equals 3. That means this will be x square upon x plus 1 whole square plus 2x square upon x plus 1 equals 3. You can now let x square upon x plus 1 to be another variable, y square plus 2y minus 3. If you just solve it, I think you will get y square, y square plus 3y minus y minus 3 equals 0. In fact, if I just y equals 1 and y equals minus 3, that means x squared equals x plus 1, x square minus x minus 1. I think it's d is positive. The two real roots can be solved d positive, and I think that's simple. Your Sridharacharya's rule, s equals to 1 plus minus root 1 rule, that is, these are the two real roots. So the real roots will be 1 plus root 5 by 2, and another root will be 1 minus 5 by